So hi, in today's lecture we are going to see that how to find the square root of a number. Okay, so they will be giving us a number, let's say 64, and we need to find the square root of this. So it's definitely 8. If I have 100, then the square root of this is 10. Now in the question they are saying us that if a number doesn't have a perfect square root, then we have to return the floor value of that. So let's say if I have a number like 109. Okay, now if I try to find the square root of this number, it is turning out to be 10 point something. Okay, so I have to return the floor of this number, so it is 10. Okay, so I believe that you got the question. So the first and the foremost approach will be the brute force, in which what you can do, let's say if I want to find the square root of 64. Okay, so I will be having the value of I that will be coming from 0. Now for every I will be finding the square of that. So 0 into 0, it is 0. So if it is not equals, then I am going to increment it. Then it will be 1. So the square of this 1 will be 1. For 2, it is 4. For 3, it is 9. For 4, 16. For 5, it is 25. For 6, it is 36. For 7, it is 49. And for 8, it is 64. So when I got the value which is matching with this x, so I will be simply returning this 8. Okay, but what in this case? Okay, so I'll try to write the pseudocode, then I'll explain this to you. Okay, so for I will be coming from 0, I is less than n, I plus plus. Okay, this will be not n, this will be x. Okay, if I cross I is equals to x, then I'll simply return the value I, because I found the square root. But in other case we have to go further. But the thing is that since we are running from 0 to x, okay, so obviously we can't go till x. Okay, it's stupidity. Okay, so what I can do, if I found that the value of I cross I is greater than x, I'll stop then and there, and I'll simply return I minus 1 value, because we need to find the floor value of that. Okay, that's it, we are done. So this is the brute force approach. Now talking about the time and space complexity, since we are running this only for from 0 to x. Okay, someone might say that the time complexity of this code will be x, okay, order of x, but it is not. See, we are not going till x. Why? See, if I say that I want to find the square root of 64, when I got to know that the value of I cross I is equals to 64, I'm stopping there. But if in this case, okay, what I'll do, let's say x is equals to 109. So for 9 also I will be finding the square, which is 81. For 10, I will be finding which is 100. For 11, the answer is 121, right? Now I got to know that for 11 the square is 121, which is greater than 109, right? So I will be simply returning I minus 1, and since I'm returning, okay, I'll stop. So I'm not going till 109, I'm just stopping it here only, right? So approximately the time complexity will be order of root x. Okay, and talking about the space complexity, it will be simple order of 1, because I'm not taking any extra space. Okay, so I believe you got this approach. I will be requesting you, please try run it by yourself as well. Now the thing is that we have to optimize this approach as well. Okay, so approach 2. Now let's say the value of x is 100. Okay, now observing the first approach, okay, what I was doing, I was coming from 0 and I was going to square root of x, right? So since we are incrementing the value of I from 0 to 1 to 2 and so on, okay? So my observation is that why can't I apply binary search on this sequence, okay, since it is in a sorted order, okay? Now the question arises that I know my high, sorry, I know my low, but here the high is square root of x and I don't know the value of square root of x, right? We have to find that answer. So what I'll do, instead of taking square root, I will be taking x only. So the sequence will be from 0 to x. Therefore, low will be 0, high will be x. Okay, I hope you got this. So here in this case, the value of x is 100. Now, mid will be 50, right? Now, we need to find the square of this 50, which is obviously much greater than the value x. Okay, so obviously the 50 is not the square root of 100. Okay, so since we need to reduce our search space, so we will be going on the left hand side. Go left. And how can we do that? By doing low is equals to, sorry, high is equals to mid minus 1. Okay, so this will be 49, this will be 0. Now the mid will be 24. Okay, so 24 cross 24, again it is much greater than 100. So again I have to go to the left hand side and I have to do high is equals to mid minus 4. So this will be 23, this will be 0. So 0 plus 23 whole divided by 2, it will be 11. So 11 cross 11, it is again greater than 100, right? So again we have to go on the left hand side. So here this will be 0, this will be 10. So 0 plus 10 whole divided by 2 will be 5, right? Now if I find the value of, if I find the square of 5, it will be lesser than 100. Okay, so since it is lesser than 100, so obviously from 0 to 5 the square root of 100 is not present. Obviously it will be present from 5 to 10, or let's say 6 to 10. Okay, so I have to go on the right hand side. So go right. And how can we do that? By doing low is equals to mid plus 1. Now here is the catch. See, since the 100 is turning out to be a perfect square root, okay, what if the x value of x is 109? So at that time we need to find the floor value of the square root, right? So what I'll do, when I got to know that the square of mid is lesser than this x, okay, so I will be storing that answer, because it might happen that this might be the potential answer when the x is not a perfect square root. So initially it was 0, then it is 5. Okay, now since I want to go on the right hand side, so this will be 6, 10, 6 plus 10 whole divided by 2, it will be 8. Now 8 into 8, again it is lesser than 100. So go right. So low is equals to mid plus 1. Now this will be 9, this will be 10. 9 plus 10 whole divided by 2 will be 9. Okay, so 9 cross 9 is also lesser than 100, right? So again go right by doing low is equals to mid plus 1. I forget to update the answer. So from 5 it was 8 and then it is 9. Now this will be 10, this will also be 10, mid will be obviously 10. So 10 into 10, I can see that it is equals to 100. Okay, so return this 10, which is mid. Okay, so I believe that you got this approach. So the pseudocode will look like this. low will be 0, high will be x, answer initially will be 0. Okay, now while low is lesser than equals to high, we need to find the mid. So low plus high minus low divided by 2. Now we need to check if mid cross mid is equals to x. If it is, then we need to return mid. Okay, otherwise here there will be an else if mid cross mid is greater than x. Okay, if it is greater than, so obviously the value is much greater than the x, right? So we have to go on the left hand side. So high will be mid minus 1 because we are going on the left hand side. So going left, else here in this case, since we are going on the right hand side, okay, but we are storing the answer as well. Okay, so answer will be mid and go on the right hand side now. So low will be mid plus 1. That's it, we are done. Okay, now someone might say that why we are taking low as 0. Okay, because the value of x is lying around from 0 to 2 to the power 31 minus 1. Okay, so if anyone put the value of x as 0, okay, and over here the value starts with 1, right? The low starts with 1. Okay, so we are not able to find the square root of 0, which is 0 only. Okay, that's the reason I have put low as 0. Now the second thing is that my question, that do we need to take high as x? Can't we take high as x by 2? Because obviously we don't have to go till x, right? The square root will be lying from 0 to x by 2 as well. Okay, but if the value of x is 1, okay, and if I do 1 by 2, okay, to find the value of high, obviously the high will be 0. We can't actually find the square root of 1 as well. Okay, so that's the reason I have took x high as x. Okay, now talking about the time and space complexity, here we can see that we are applying the binary search. Okay, so obviously the time complexity will be order of log n, and since this is an iterative approach, so the space complexity is 1. Okay, so I believe you got this. So we can find the square root of any number by using the binary search as well. Okay, so that's it from my side. I'll see you in the next lecture. Till then, keep practicing.